it has already been seen that there's a difference between the simulation and the physical robot. The root of this difference is the sense in which the motor of Joint 3 turns. So the programs are thought for the physical robot, but there's this difference with the simulation, so that when the motor increases its value, its angular value in the simulation, it rotates to the right when it should rotate to the left. It doesn't matter yet because we're not trying to reach any specific position, but in following tasks, we will need to reach some point. So now we will demonstrate that this difference exists, and in other tasks, we will see how to solve this problem. This is the same code as the one to move only one joint each time. But since we are only interested now in seeing the third joint, in this part I've commented everything except for moving to the initial position and the two movements of the third joint. Okay, so in the first movement, the angle increases. In the real robot, when the angle increases, the tool should go up, and when it decreases, the tool should go down. But as we will see in the simulation, it is exactly the opposite. This is because the sense of the motor in the simulation is reversed with respect to the real sense of turning of the motor. So here you will see in the simulation that when the angle increases, the tool, as said before, should go up. But in this case, it is going down. This is because the sense of the robot is reversed. Now we will see in the real robot how it behaves. So before touching anything, I want to show this right there is the third joint. So as usually defined in this kind of motors, when the angle is reduced, it should turn to the right. A turn to the right implies this movement, which you will see that the tool is going down. And when the angle increases, it will turn to the left, and thus the tool will go up. As was seen in the simulation, it was happening just the contrary. But in the real robot, now I will power it on. In the real robot, everything happens as it should. See? If you remember the points, first the angle was increasing and then it was decreasing. Because of this, when the angle increases, the tool should go up, and when it decreases, it should go down. So let's see it again. Now the angle will increase and the tool goes up, and when it decreases, the tool goes down. This is the initial position. In this video, it has been demonstrated that there's a difference between the simulation and the real robot. Until now, it hasn't mattered because we were not looking for a specific position, but for following tasks like the inverse kinematics or the pick and place application, this will be important and the program must be adaptive so that the changes are coherent.